welcome to Learn Data. It's great to have you on the channel. I'm Nilesh and today we'll continue to learn about pandas. In this video, we'll talk a little bit about how to concatenate data frames that are stored in a dictionary. And next, we'll look at how we can append a series as a row to a data frame. Moving on, we'll look at how to append list of dictionaries into a data frame. And finally, we'll look at a very important concept of what types of joins are there: outer join, left join, right join, inner join, and we'll use the merge statement to see how that works. Finally, after that, we'll look at how we can handle duplicates in data frames when we are joining, and how we can join multiple data frames at once. So before we get into Jupyter Notebook, let's first look at the concepts. Outer join. Here we see there is a table on the left which is metal, which has two columns, metal and day. There is a second table which has two columns, metal and month. Now here I'm referring to these as tables. When we work in Jupyter Notebook, these would be called as data frames. So it's one and the same thing. Now when we say that we are going to join a data frame to another data frame, or if we are saying we are joining one table to another table, what we are trying to do is first we need a column that is common in both the data frames that we can use to join. So here we have a column which is metal that is common in both the data frames, and it has the quantities gold and silver and gold and iron. So those are the items within that metal column that will be used for join condition. In some cases, this column may not be called by the same name. For example, this could be metal 1, this could be metal 2, but it doesn't matter. What we care about is what's in that column. Alright, so here we have gold, silver, here we have gold, iron, and those are the two items there that we are going to join. In outer join, what we get in the output table after join is all the records from both the tables. So for instance, when we do outer join on these two tables, we match gold with gold and we bring the value from the day column and the month column and put it here. So we have gold, and the reason why it's color coded red and blue is because it's common to both. Here we get the Saturday, which is from the left table, and we get month, which is from the right table. Next we have silver. Silver is present only in this left table, it's not in the right table. So we get the values for silver in metal, Tuesday for day, and the month remains NaN or empty because that particular joining label that we are using, metal silver, is not there in this table right here. After that, we come to the table on the right hand side and look for any remaining metals that we can match, and there is one which is iron. However, iron is not present in table that's on the left hand side, so we bring iron in the output, but then for the day it's NaN because that particular metal is not there in the left table, and so there is no associated day value that we can put here, so that's why it's NaN. However, we do have the month for iron, so we put the month here, and that's the simplest way of looking at a outer join. Now let's look at left join. As you have probably already guessed, what left join does is it prioritizes the left table in the join and brings all the rows, all the keys from that table into the final table. So these gold and silver, we can call them as keys, like a primary key, and both of those will be in the output table. when we looked at the outer join, which is here, keys from both the tables were there. So we had gold, silver, and iron. All the keys were there in the final table. But in the left join, only the keys from the left table will be in the output table. Okay, so gold and silver. So we join gold and silver, and gold, because it's in the right table, we get the month of July, and silver, it's not there in the right table, so we get NN for month. Iron, that is ignored because iron is ignored because it's not present in the left table. Okay, now let's look at the next join, which is right join. It's exact opposite of left join. So in right join, what we care about is the keys and data in the rightmost table. So whatever is there in the right table, everything goes into the output, and only those values from the left table are in the output that match with the right table. So here in the right table we have gold and iron, and again out of these two only gold matches with the left table, right? So from the left table we can get the Saturday here, and we have the July. However, when we try to match iron, it's not there. But because this is a right join, it goes into the output table, and for day we put NN, and we have the August here. Okay, now there's another way we can do the join, which is the inner join, and this I feel this is the most commonly used join that I've always worked with. What the inner join does is it picks only those keys or those items that are common in both left and right. It ignores all the items or all the data that is either in left table or either in right table. So it has to be in both, otherwise it's all ignored. Now the only common key, if we look at between these two tables, is the gold. So gold is in the left table, gold is in the right table, and we get the gold in output, and that has the day, which is Saturday, for left, and the month is July for the right table. So here the silver is ignored because it's not in the right table. Iron is ignored because it's not in the left table. So that's how the inner join works. Now this is something that you'll probably encounter it sometime, and this can happen with any type of join. Here I'm giving one example of inner join only. In previous slides, the keys that we saw, gold and silver, gold and iron, they were unique. I mean, they were not duplicated. They appeared just once in that table. However, as if you look at the right hand side table here, right table, here we have the value of key of gold appearing twice in that table. Now if that happens, if we try to do an inner join, we are going to match on the keys that are common in both the tables. Okay, so here we have the gold key that is common in the left as well as on the right. Now when we try to match it on the right table, which is this one, we end up matching it twice because it appears twice. So the first match is with gold here, and we have the month of July. So in the output table we get gold with July, and the second match is with this gold with the month of March, and in the output table we therefore get gold with the month of March, and the value of day for Saturday is common for both of them. So that's how the join could work in case of duplicate keys. And this is a very important point because sometimes if you have a data set with thousands of rows, and if there are say 500 rows or a couple thousand rows somewhere in million records that are repeating, so if the keys are repeating, when you try to join them, the output data table that you get explodes, and that can be a problem. So one way that I used to check uh, if the join has any duplicates, if I'm doing an inner join, is always see if the output table size is not greater than the table that we already have, right? So if we have, for example, here we have a table that has only 2 records, so output table can have maximum of 2 records. It cannot have more than 2 records. If it has more than 2 records, such as here, then the chances are that there may be a duplicate key somewhere in there. Okay, so this is very important to understand. If you still are confused, I'd suggest going back to the slide 1 and kind of revisiting and thinking through how the joins work. Now we'll get into Jupyter Notebook. So here we have ton of data today. So I've already typed it to save time and make the video a little shorter. We imported 3 libraries: NumPy, Pandas, and matplotlib.pyplot. Then for data we have a one series which is H, and it has these 4 elements, and I've added indices to these because we'll be using those later on. Then we have these 4 data frames which are from the previous video. We have df1, df2, df3, and we have df4. If you need to copy them, you may have to pause the video. Next, we have these 3 new data frames. In here I've added these 2 columns, which is color and shade, and the reason for those 2 columns is because we are going to use those 2 columns as keys to join data frames together. Just as we saw in the slide, we had metal, gold, and silver. Here we are going to use color and shade to do exactly the same thing. Finally, there are these 2 additional data frames which I'll discuss towards the end of the video, that show some updating rules that you may use sometimes. Okay, so let's get started. And first what we are going to try is use a dictionary of data frames. And let's go ahead and create a dictionary. We already have the data frames created, so I'm going to label this dictionary as df_dict, and this is going to be 1. That's just the key name, and here we are going to give the value as DataFrame1. Let's put 2, and for this one let's give DataFrame2, and this is 3. Let's give this value DataFrame3. So that is our dictionary. If you do not understand how dictionary works, I'd suggest revisiting the video on dictionary, in which we have discussed this in a lot of detail. Now to concat all these data frames that are present in a dictionary, we need to write, let's say if the output needs to be data frame df, then we say df is equal to pd.concat df_dict, and that's it. So when we run this, we get a dictionary which has the 4 columns M, N, O, P, and the keys from the dictionary are also added here as labels, row labels. So here if we were to pull 2, so that would be df.lock 2, then we should, well, if we do def name 2 is not oh sorry, the reason is because there's no quotes in there. So when we want, if we pull the label 2, we get the df2 dictionary out of that particular data frame we just created. Moving on, we can also pick and choose data frames from that dictionary. Let's say if we do not want all the data frames from that dictionary, we can specify the labels now. So this we can write df underscore dict, and keys is equal to, let's say we want 1 and 3. We don't care about the dictionary, we don't care about the data frame number 2 in that dictionary. So here we appended or concatenated only 2 data frames from that dictionary. Now let's look at how we can append a series. So append a series as a row to the data frame. For this we already have our series created, which has the same indices which are columns in our data frame df1, which is this one. So what we are going to do is put this column h1 through h4 right here at index 3, and to do that we'll create a new data frame df where df1.append h, and here we can specify ignore index is equal to true, df, and now we can see that the series is appended as a row to this particular data frame df1 and stored in a new variable df. Next, let's look at how we can append dictionaries into a data frame. So list of dictionaries into a data frame. For this we are going to create a dictionary. We are going to create a list of dictionaries. So this is our going to be our dictionary 1, this is going to be our dictionary 2, and in this dictionary let's create key value 4 key value pairs. This is 1, and we'll keep the same naming convention because we are going to append it to the df1 that we already had earlier. So this is going to be MNO, and let's put this 7, and then we have MNOP, and let's make this 9. So that's, and we can also go ahead and add one out of the box column, is sun, and let's call this 1. And now we can copy this, paste it here, and then go ahead and change the values so that they're different. And this can be 6. Let's make this 0. Let's call this moon. Okay, we have this dictionary. We have this list which has 2 dictionaries. One is this one and the other one is this one. Now to perform the append, we need to specify df is equal to df1.append data, and ignore index is equal to false, and sort is equal to false. Now when we run this, here we can see that both of these dictionaries have been appended, and they are put along with this particular previous dictionary that we had, which was the df1. So now we can clearly see how this had worked. So we have MNOP, which are these columns, and the values for MNOP from the dictionaries, so 3, 4, 7, 9, they appear here. So these are appended below the existing dictionary, existing data frame df1, and the values for 2, 5, 8, 6 appear right here. Sun and moon, those 2 columns were not there in df1, therefore after the append, those 2 new columns were created in the output data frame df, where the NaN suggests that those values did not exist in the other data frame. So that's why they are blank. it existed only in the first dictionary, so we have that value of 1, whereas it did not exist in the second dictionary, therefore it's NaN. Similarly, we have 0 for the second dictionary, NaN for the first dictionary, and all NaNs for the DF1. So that's how we can use a list of dictionaries and combine them into a data frame. Now moving on, let's look at how we can use the merge statement to perform different types of joins with the data frames. And we have already looked on the slides as to how the conceptually understand how different types of joins work. Now we're actually going to code them to see if we get similar results. So for for here we are going to use two data frames. Let's say DFC1, which is this one, and let's use DFC2, which is this one. Now the keys that we are going to use for joining are going to be the column color or column shade or both, and I'll mention that while we are performing the join or merge. Now first let's perform the default merge. So df is equal to pd.merge dfc1 dfc2 on, here we specify the column that we would like to merge or match the two data frames. They are also called keys, and when we run this, here we matched on the color. Now the color for the data frame DFC1, we have red, violet, blue, green, orange, so we get red, blue, green, orange. The violet did not appear here, and if you look here we have red, blue, green and orange. So red, blue, green and orange, so all those are there. So that is the default one. Now if we copy this, run this, and if we specify how, and if we say outer, here you can see that we got the violet as well. So we got all the possible combinations in the output column. Here I think what this did is probably did an inner join. Let's check if that is the case. If we do an inner join here, so I'm gonna copy this again, put that there, and how, if we say inner, now for inner we see we get red, blue, blue, green, orange, and then we have dark, 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 light, dark. We have Q1 through Q5, R1 through R5, dark, K1, K5, J1 through J5. So here it seems that default is inner join, and that's what we get right here as well. And we saw the inner join, we saw outer join. Let's now go ahead and try the left join. So I'm going to create one more row here, and let's try left. So in left join we expect all the records from the left table. So here the item that is specified on the left hand side, so we are specifying DFC1, that is the left table, and the second one DFC2, that's the right table. And we see all the columns, all the keys, red, violet, blue, green and orange, red, violet, blue, green and orange in the output table. The reason why blue appears twice is because blue appears twice in the data frame that's on the right hand side, which is DFC2. And this looks good. Now the question you may have is, why do we have this underscore X and underscore Y in the column names? The reason is because when we are joining two tables or two data frames, and if they have the same column names, what this is trying to do here is trying to differentiate them so that they maintain their identity as coming from separate columns. So shade underscore X tells that this is column that came from the left table. Shade underscore Y tells us that that is the column that came from the right table. and as we can see, this says dark, light, dark, light, dark, and that's what we have here. That's how the left join works. Now if we were to change this and see how the right join works, it's going to be exactly opposite of what we did just now. So when we do the right join, here all the keys from the right data set would appear in the final data frame. So here we have red, blue, blue, green, orange. There's no violet, so we should not see violet here, and we do not, so we get red, blue, blue, green, orange, and violet is not there. Again, to maintain that the identity of the columns that they are coming from that particular table, the shared underscore x in this case represents the DFC2, which is it represents the left column, which is dark, light, and shade y along with kj represents the table that's on the right hand side that we used in the right join. Now we already saw the left join, we saw the right join, we saw the outer join. Moving on, let's see what we can do with two keys as join conditions. So if we put this here, and instead of saying on just color, if we say we want to match them on both color and shade, okay, and let's use inner join for now. So again, if we pull the DFC 1 and 2 down here, it won't fit in the page. So let's see, DFC 1, we have red, dark in the left table. Let's see if we do have red, dark in the right table. So the condition for key 1 color, key 2 shade match in both left and right tables, and therefore we see that key and associated row data in the output table, which is red, dark. Next, let's look at violet, light. There's no violet light, so we do not see that data keys or associated data in the output table. Moving on, we see blue, dark, and we do have two blue darks in the right table, so we do see associated both of the blue dark keys and their rows in the final table. After that, we have orange. Let's see here, we have green, light. We do have green in the right table, but then the shade does not match. It is dark in the right table, whereas it is light in the left table, so that's a no-go. So that key pair and the associated row data does not appear in the output table here. Moving on, we now have orange, dark, and we do have orange, dark in the right table. So both the keys appear in both the tables, so they match, and therefore those two keys along with the associated data for that row does appear in the final output table, which is DF. I hope you got an idea as to how the joins work, how merge works, and because that's really important. And this is directly, if you already have a programming background in SQL language, this might be much easier for you, but if you do not, I'd suggest practicing this a little bit to get a clear understanding of how different types of joins work is very, very important. Now let's move on and look at how, if there is a way we can check duplicate keys. So just as in the example above, we saw that the blue color was appearing twice. So here, let's see if we can find a way to check that. So we'll go ahead and do a join. So pd.merge, and we can use the same two commands. So dfc1, we can do dfc2, on, and this time we'll just go ahead and use color. And how let's do we can do outer join, and here we can specify validate. So what validate does is it checks if the joins are in that particular requested checking order. So if we say 1 to 1, it means that it has to be 1:1. So there cannot be the same key appearing twice in either of those two tables, DFC1 or DFC2. So we already expect this command code to fail because we know that this key blue appears twice on the right table, which is DFC2. But we will still go ahead and run this, and as you can see, this failed. Merge keys are not unique in the right database, not a one-to-one merge. So this is really helpful. One slight downside of using this could be that if the dataset is too large, it may take more time to process the join because it's going through that row by row iteration to check if there is a duplicate in key anywhere in that particular table. Here, if we replace this by one to many, then we can see that the condition did not throw any error. It means that that particular condition was satisfied, and the reason why it was satisfied is because this blue is once in DFC1, but then it is more than once in DFC2, and therefore that was okay. That validated that particular condition and everything ran successfully. Moving on, let's look at how, if there is a way we can use indicators that could tell us what type of join was performed to get that any given row. So if we say df is equal to pd.merge, and we'll go ahead and use the same dfc1 and dfc2 on, and we'll say color. Now indicator, what indicator tells us is what type of join was done, or what type of condition was there for the join. So if we say indicator column, and if you run this, here we can see that this was in both, and because this is inner join, here if we specify how is equal to outer, then now we can see that if this, for this second row, while with the color violet, this one was present only in the left table, and therefore it says that that's a left only row join that happened there. So that's why here this is NaN. And so this indicator parameter can be used if we want to check what the join conditions were in the final output data frame. Next, let's look at, so far we have been joining based on the values that were present in a column data. What about joining on the indices, row index? How can we do that? And we can do that. So let's see if we can join on index. So this would be row index. And here what we can do is pull our data frame df1, see what, okay, we'll go ahead and modify this little bit. What we can do is add indices to these, and if you remember from previous videos, to add indices to a data frame, we want to specify pd.index, and here we can give these names, and those names could be any type of name. We can say maybe A, B. We have 3 rows, so we need three of these, and we can give this a name, and this could be, let's call it data1, and then when we run this df1 again, now we, okay, sorry, this we need to specify name is equal to, okay, that should work. So now we have the data frame df1 which has labels a, b through c, and we have also given that index column a name, data1. Similarly, we can go ahead and change the df2 where we can give, let's change the indices a little bit. We'll add b, c, and one that does not exist in the other one, and make this df data2, and we run this. This is the second data frame we have. Now let's use the merge command. So df is equal to, let's bring this up, pd dot merge df1 df2, and this is going to left underscore index is equal to true because we are going to use that as a key to join, and then the right underscore index also true because we are going to use that. And let's try the inner join where we have df, and here we can see that for the column, the keys index for df1 and df2, there is b and c. Those are the only two that are common in both, and therefore the output has data associated with rows with index b and c only. Here the suffix x suggests that this is from left table, which is df1, underscore y suggests this from the right table, which is from the table df2. Now here we had both indices. Now what if we were to use index and a column? So for that we would have to modify our table a little bit. So we have df1 which has these values. Why don't we go ahead and change that? So for m, we can replace those m1 m2 m3s with letters a, b, and c. When we do that and run our df1 again, we should see the abc there. Now the column m has those values. Here if we go back, paste it here, and for the left, this time what we are going to say is left on. Because we are joining on column, we have to specify the column name, and for that we need to specify the left on instead of left index. And when we run this, we get the output where we have the m which is joined on the values that were in the column m, which were b and c. A did not match and therefore it did not appear. D did not match and therefore it did not appear. So the difference between the earlier and this one is, here we matched the values in the column m of data frame df1 with the keys in the index column for data frame df2. Let's now look at how we can join multiple data frames. Join multiple data frames, and here we are going to use, let's create x is equal to dfc1, where we are not going to take all the columns. dfc1 has we'll take the q and r column from there, and for dfc2 we have k and j, so copy paste xy. I'm going to take k and j, and then for dfc3 there is e and w, so I'm going to take e. What I'm doing here is removing the column names that appear in both columns, so we need unique column names. Okay, that should work. So we now have three data frames x, y, and z, and if we are looking to combine them, so the way to do that would be x dot join, and within a list we want to give y and z, and when we run this, this is the data frame which we get, and this is now joined on the index of each data frame, and therefore we have in the final columns QR, JK, and EW. Now moving on, let's use the combine and update functionalities. Let's see how those work. Combine and update. And for that, I'm going to go all the way to the top and copy these two data frames, bring them down here and paste them here. So what we have is DFN1 that looks like this, which has diagonally NANs, and then we have the values in the other diagonal side, and in this we have NN which is only at index 00. So if there is a situation where we need to update this original data frame DFN1 with DFN2 such that only the NANs are updated if there is a new value in the new data frame. For example, here this is NAN in column B row with index 1, whereas in the DFN2 there is a value of 8687. So we need this value to be put instead of the NAN, and to do that what we want to type is dfc1.combine first dfn, this has to be n1, and we want to type dfn2, and when we run this we get a new data frame which has the NN from the first data frame replaced with a new value that we have from the DFN2, which is put here. Similarly, there is another command which is update. What that command will do is it will update not only the NANs, but it will also update these values if they exist in the new data frame, and it will leave the NANs as they were. So if we try dfn1.update dfn2, what we get now is, if we look at dfn1, it is now updated such that it not only replaced the values 999 by 1, but it also replaced the value for 7 with 777 and replaced the NAN, which was this, by 8687. So that was it for this video. I hope you enjoyed learning how joins work, how concatenation works, how appends work, and most importantly how the merge process works. Different types of joins: outer join, inner join, left join, right join. I'd suggest going back and looking through the slides again to see if you have a clear picture of how those work. We'll be using lots of these in coming projects, so this was a really important and interesting topic. That's it for this video then. I'll see you all in the next video. Please like, share, and subscribe. It helps me stay motivated to create more videos for you all. Thank you, and see you all in the next video.